Welcome. I'm Nell Syntax. This is my channel. I know that I have some subscribers from years past. Uh, that was probably because of my KSP display, the physical one. That's probably, I would say, around 10 years old now. I decided to get back into this. I wanna show different people who are interested in technology and potentially homebrew and things of that nature, what it's like to kind of stumble, discover, build, program, hack, tinker, all your way to having a working product. So I've done a bunch, and I'd like to share some of them with you. And I would love for this channel to be community driven. I want to keep it more along the lines of like this, a live stream. And with this live stream, even potentially having different individuals, give a suggestion or even take polls on future projects. So I'm going to start out with, something that I've been, kind of working on. It's a Homebrew 6502 computer. So I'll show you guys exactly what I've been working on here. So this is my Homebrew 6502. I've been building it probably, I would say, over the course of the last, I don't know, 3 or 4 years, but very off and on. And only as of recently have I really done even more work on it. It's got 32K of working RAM right there, static RAM. It's got a 16K ROM, a custom keyboard decoder made from a PIC microchip that I kind of programmed. It's got an ACIA for I/O of that keyboard, and then 8K of dual port video RAM. And alongside of that is an FPGA that I kind of taught myself a little bit of VHDL. It's not pretty, and I'm sure I'll show you, that code and what that looks like, or I should say the descriptor language, and what that looks like, perhaps potentially in a future video, and we can see, together if we can improve upon it. Right now, it's set up. You see all these resistors here. It's set up to do multiple colors. I have a whole test that I did that does show that the multiple colors does work, but the VHDL on it is not perfect yet. So currently, what it is it'll run 640 by 320 divided by 2. Basically, it doubles the scan lines, and it does character-based, image. So 256 characters can be loaded into. This is the working 32K of video RAM that the actual FPGA uses, or as I call it, I call the whole system the Danny 1. It's named after my wife. But the Danny 1 has a VGA module that I programmed onto the FPGA, and it's got 32K of working RAM, and it uses this 8K of video RAM as kind of like a screen buffer, and I'll kind of explain what that looks like. It kind of looks like a screen buffer, and then including in that screen buffer, it actually also uses it almost as like pseudo registers to communicate with the FPGA. Granted, I probably should have just made the FPGA have registers, and do it the right way, but it works well for this matter. Currently, everything that's been implemented is at the point where I need to be able to communicate pretty much with, I would say, a PC at this point, to easily transfer data over to the 6502. Right now, it's a little cumbersome to get it over to it, but I just finished porting Enhanced Basic over to my custom monitor for this thing. So I'd be happy to kind of show you guys what that looks like. Gotta have your coffee. I'd like to show you kind of what that is and how it looks, and all the little nuances that I kind of went through for that. My ROM image for this system that I built here, it is open source. It's on GitHub. I'll probably post in the comments if anybody's interested where my GitHub repo is, and you can take a look for yourself. But let me actually open up real quick the main start of this system ROM. And you can see right off the bat what I have here. Sorry, I'm just getting this all configured. And this is kind of a little bit of a very odds and ends stream. I kind of want to show you what it's like to actually work in real time. So I know I don't have fancy editing, and it's a little bit more of like seeing what it's like to actually go through and troubleshoot and figure it out on your own. But I'll show you what I currently have kind of already set up. You take a look here, you can see the first 32K of this system is all of my static RAM, which, like I said, is this chip right here, this static RAM chip. And that runs from 0 to 7 FFF, and then 8, the 4K that I'm using of this 8K dual port RAM is right here. And that runs from 8000 to 8 FFF, and that's my video RAM. The 9000 to 90FF is going to be the VIA, and that or I'm sorry, that is the VIA. It has been implemented. That is this chip right here, and it's just that 1 byte, and that's how we kind of got a timer on there, and not only a timer, I also have on there a port, and there's another open port, and I use 1 port for the keyboard. It's basically 1 byte at a time transfer. We don't have the ACIA, so I misspoke earlier, actually implemented yet, or the PIA. I do have those chips. I do plan on eventually kind of doing an implementation of it, and I've already carved out areas in DMA or my memory addressing scheme that I plan on accessing that. And then there's a 16K, right here it is, a ROM, that runs from C0 to the end of memory, all the way to F. So currently, my ROM monitor, prior to maybe the last day, literally implemented, and I'll show you real quick. I call it the Commander. Not named after anybody's Commander X16. This was implemented years and years ago. It's just Commander because it allowed me to enter commands. But as you can see, here we have a couple of just rudimentary type of methods. One for peek, one for poke, jump return. So, you know, if you put some custom assembly language, or I should say machine code, into some place in RAM, you could jump to it. And then dump, and that just gives me an on-screen, you know, dump of an area of memory. Write, which is kind of interesting, and I'll show you when I'm up and loaded. What write allows us to do is it allows us to hold on one second. Sorry about that, stream. What happens when you're running live? Alexa starts. Probably just heard that. Oh, good. No, she doesn't. Write, which I'll show you, and what write is it allows you to start at a place in memory and just enter a byte at a time, and it'll continue to enter 1 byte, 1 byte, 1 byte in a sequence. And now this command called ehBASIC, which is pretty interesting. It actually jumps to kind of like a little bit of a bootloader, and this bootloader basically gets us into Enhanced Basic. Now, I've run this on simulation, but I have yet to run it on actual hardware, so I plan on doing that today. I want to get this running up on my 6502. As you see on the screen here, you have on top the project that I'm working on here. In the middle is the 6502 that goes through a VGA output. That is my custom FPGA VGA output. all the way into HDMI, VGA to HDMI, and then it's captured. So that's what that little floating box is right now. It says nothing's turned on, nothing's running. So in just a bit, when we finally get this up and running, we'll have that. We'll make it full screen, and we can kind of tinker around. But currently with this code, when I do type BASIC into the commander, it drops us in over here. If anybody here has worked with enhanced BASIC before, it's really a great drop-in for 6502 PCs. It's a version of BASIC that is designed to really run on 6502s regardless of the kind of characteristics or design of the computer that you build around it, really. It's super powerful and it's super small. It's written by a gentleman by the name of Lee Davison, I believe his name is. And it's been patched and updated and, you know, community driven to the point where now it's even beyond some of the things that he has done. It's included bug fixes from gentlemen on the 6502.org forum, which is a great resource for anything 6502. And it's really nice to see such big support still around 6502s in general. Now, I noticed that probably a bunch of you who have been subscribed to my channel in the past, you're not going to be able to see this stream live more than likely, unless you just happen to stumble upon it. So please, if you're watching the video and you are seeing it after the live stream took place, and you like what you see and you're interested in kind of just tinkering around with electronics, building hardware, building software to support that hardware, just doing kind of really cool projects, do a like and subscribe, hit the little bell, so when I'm on next time, you can participate live. That would be really neat. So what I have to do actually today, and I'll show you, is get this enhanced BASIC code that I've already created, or I should say this new ROM that's updated with this enhanced BASIC on here, and I got to get it over to our 6502. So in order to do so, I'm going to actually just pull this out real quick. And I know I'm probably going to get complaints that I'm not using a IC puller, but that's okay. This is the 16K ROM that I use. It's actually a 32K ROM, but I'm only using 16K of the addressing space on it. And I'm going to program it after I assemble the current ROM that I've been working on with this updated ROM, and then we'll plug it back into the machine and we'll boot it up and see if we've got BASIC working on it. So in order to do that, I don't have a ROM programmer. So I looked at the white sheet for that ROM, and I've created what is more than likely the most disgusting and ugly ROM programmer board I've ever seen in my entire life. I do have a tip thing on here. If you tip, maybe I can actually get, or if you like what you see, maybe I can afford to go out and get one of those official cool ROM programmers. But if not, this is the way we do it here. We just build it ourselves. And once we build it ourselves, we create some code around it, and we make our own ROM programmers. So this ROM programmer is built off of and around a PIC 18F46K22. Now that is a DIP package. It's a large DIP package chip. And the reason that I did that is, I want all 8 address lines, or I should say, sorry, all 8 data lines, and then I think I use 10 of the address lines, and I want them available, and I don't want to do any type of flip-flopping in order to, like modulating to access that. I just wanted to kind of put it out to the ports and write. So I used an extra large chip with a lot of I/O, and not only that, it holds onboard memory a full 64K, which means that I can essentially, even though I'm only programming 16K, I could potentially program 4 16K chips or 2 32K chips just using this one thing. And in order to make this actually happen, we're going to open up MPLab. which is a nice piece of software that comes with any type of, I should say it's actually freeware to download, that allows you to program directly onto a either PIC micro of 8, 16, or 32-bit series, or AVRs as well, because Microchip ended up buying AVR. I have a PIC Kit 3, and that's what we're going to end up using today, this PIC Kit 3. We're going to hook it up to, essentially this chip, and then we're going to throw our ROM image on and program our ROM, and then we'll put it back in the 6502 that we've created. So, in order to do that, first thing we'll do is assemble. So we're going to go back to the actual main entry point of our application, or I should say our ROM. And I'm using Kowalski's macro assembler and simulator. It's actually running up to version 1.3.4.7, which has been majorly overhauled and extended past the original 1.2.2.2, which Michael, he's the one who originally officially wrote that far. And now after that fact, it's been taken over by the 6502 community once again. Specifically one gentleman in the community, and I can't remember his name off the top of my head, so please forgive me. But here's what we're going to do. We are going to open up, we're going to assemble this. So that quickly, it actually assembled pretty quick. We are going to save this code, and I am going to throw it right here, and I'm going to call it Danny1 ROM. So we're going to set some options on it as well. And the options is we're just going to tell it that it begins at C1000. Remember, I had mentioned this before. If we take a look at where the ROM is, it starts here at C1000 and it runs to FFFF. And I just wanted to make sure that, it's 16K in length. So just setting that option does well. I think that there's already the file there from an old build that I had, so we're just going to hit yes to replace it. And then if I show you MPLAB, how I actually get this over is a little interesting. I actually take the ROM and I create kind of like a header with it. It's basically an array of bytes. And this allows me to kind of just get it onto the PIC 18F46K22. And once it's on the PIC, from there, we run some, some code that I wrote that basically programs it, and then it does like a check. It reads back and sees if everything that it programmed exactly equals byte for byte what it was supposed to be in that ROM binary. So what we need to do is update our ROM header. So I'm going to use a tool that is a part of DASM. I'll bring this over here, you can see. It's called XXD, and if you pass the switch of -I to it, I'll just show you all the switches real quick. You take a look at all the switches here. The one that I'm interested in is -I, which outputs in a C include file style. So we're going to make basically a header out of this, and it automatically formats all these bytes in an array. So it's just XXD -I, and we're going to get that sysrom bin that we just dumped out, and we are going to make a file called rom.h. Actually, I'm going to delete the rom.h that's already here. Actually, it's not even sysrom. I would have built the wrong one. It's DannyROM. So that sysrom must have been an old one, so we'll just get rid of that too. So XXD, we'll take the DannyROM, and we'll create a file called rom.h, and you'll see it creates it, and then I will open up rom.h in an editor, We'll use Notepad++ for this. Give me 1 second as I get that open. There we go. And from here, because the variable name does change up there, what I'll do is I'll just copy the contents of this binary, and we'll come on over into MPLab, and we're just gonna paste it right over what was originally in here, and then we'll save it. So now we're ready to pretty much program our chip here. So in order to kind of go ahead and do that, the first thing that we have to do is we have to get our chip put into this board here. So I'm going to do that real quick. So there it is right here. I'm going to go ahead and just plug this chip in right on our breadboard. Should take just about a second. And I kind of had lately 1 or 2 issues with this programmer that I've created. Hopefully it doesn't give me an issue now. But I think one of the cables, or I should say one of these jumper wires, are a little on the loose side. And what happens is, as you can see, the rat's nest that it is, it prevents 1 or 2 of the bytes from writing. So what I'm also going to do is I'm going to hook my PIC programmer up to this, and we'll plug it into the USB port on the PC. Some USB sounds? No, you don't. Oh, there it is. Yep, you do. And we'll hook up each of these by the pinout. First is that master clear. Then we have VDD, followed by VSS, ground, and then our data, and then finally our clock pin. Now, one thing that it does require us to have in order to program this chip is it does require us to supply power to the board. The PIC Micro or the PIC Kit 3 can, in options, power your circuit, but I've found it to be unreliable unless you're doing something that consumes very little power. So I'm going to supply our own power supply to this, which is just set to 5 volts at 2 amps. So we got plenty of current to really power that. I'm going to turn it on. And we're going to go ahead and hit debug. And what this will do is we have a while one here. If there are no errors, eventually this will break here. And that's when we'll know that the program is complete, or the programming is complete. So we're going to hit debug, and you'll see at the very bottom a number of things will take place. One of the things is it's going to take our nice ROM that we threw into a header, and it will program it into the PIC18F46K22. So we're going to see a little bit of output here. It's talking to the PIC 3. It has noticed that we have a PIC18F46K attached, and it's right now programming 64K of program memory on it. So it's going to do that. It's going to take a minute or two here to do that. It already finished. Okay, so now it's running. So what should be happening right now is this should actually be programming that ROM chip. And if we give it a couple of minutes here, we should be able to determine that when it has a break in the debug, that the ROM is then successfully fully programmed. So we're just going to give it a second and see what happens. Hopefully it's good. And this does take a minute or two to program. I'm sure that there are other programmers out there that are a little quicker than this. This is a pretty good EEPROM though very fast. I believe it's 100 nanosecond or 150 nanosecond EEPROM. I got it off of DigiKey by doing a product search. So, a couple more details about the 6502 that I'm running while this is programming. The 6502 has got a 4 megahertz crystal on there. So I actually have the 6502 running at 4 megahertz, which it's a 65CO2, which means that the processor is one of those WDC ones that are built on CMOS logic, which means that we can run it at a much faster speed than MA's 6502, which was that NMOS logic was able to run at, or that TTL logic, really. We're gonna see if it got stuck here. I'm gonna put in here in just a second a pause, and we'll see where it is actually in the programming state. Because I can pause it right here, and it looks like if we step through this, that it got stuck. Let's just double check. Yeah, see, this is actually at the point where it's trying to read back what it wrote. And it's not coming back with the right information, which means, like I said, one of these cables on this thing is just either really loose or is not really, in there all the way. So what I'm going to do is I'm just going to kind of push down on some of these cables that I have on this programmer that I made here. And what we'll do is we will attempt in just a moment to program it one more time. And I have a pretty good idea of what we can do to see if it's working almost immediately. We're going to run it one more time. And we're going to give it a second, and then we're just going to stop it and break in. And we'll see. If it gets stuck at this write data, where it needs to wait until the byte is completely written, but it's just looping here because it's not reading back the same byte it wrote, what we'll do is we will reseat the chip, which usually sometimes also helps. So let's pause it, and yeah, it looks like we're stuck there again. Step through here. So here's what we'll do. We'll actually go ahead and reset or reseat, I should say, this chip, and I am going to use a chip puller on this board because it is in there a little on the tight side. So I do want it to come up nice and evenly. Try and keep the legs intact. Legs look like they're intact. Let's reseat it on the board. I just really need to invest in an actual ROM programmer. Okay. Plug the power back in. And let's give this another go, shall we? Debug start. Like I said, we can easily just check that if this worked or not. Once it starts, we'll just see if it gets over that initial hill of reading back the first byte. Okay, it's running. So we'll pause it. And we'll see where we're at. Hey, it looks like this is working. So we'll just continue. We'll give it another second here. We'll pause it once more and make sure that we're still rocking and rolling. I'm going to leave it. Let's just double check. Okay. Yeah, we're rocking and rolling. We're going right past that point now. So we're just going to continue. All right, so this should program, and this is why I wanted to really kind of run this channel this way. I want you to see, you run into things when you're building this. I mean, I know that a lot of different channels kind of have the pre-canned, edited out different areas, but you know, I kind of wanted to show what it's actually like as you're building these things, as you're going through it. So we'll give this another couple of seconds, and once we can determine that we have a successfully written this ROM chip, we'll get it plugged into the 6502, and we'll see how it runs. I think it's doing pretty well right now. Yeah, so if you have any questions specifically about this homemade 6502, even about the glue logic, how it does decoding of the memory, throw me a message here down in the comments section, and I'll be more than happy to kind of go through it and explain in more detail certain sections of it. We're getting closer, I feel it. Maybe. Yep, there we go. It's done. So you see how it halted right on here? That means that we got through the writing of it and then the reading back of it. So we're good. All right. Let's stop the program. Let's disconnect the PIC micro device. I am going to pull it out. And this should have our latest ROM code on here, the one that we just assembled. So this now has our latest assembled ROM. We're going to take it and we are going to put it back from whence it came. Bit of arrested development. Okay. All right, it's in. We are ready to power up the 6502 and take a peek, see what we're working with, and see if our enhanced BASIC that we ported over is working. Let me power back in. Power. Ground back in. All right, so clear a little spot here, and let's start up the 6502. Give it a second, and hopefully we get something. Not looking too great right now. Maybe I just don't see it. Maybe I'm having a little bit issue with... Here, let's reset it. Oh, there we go. Maybe I had a little video capture issue there. In fact, let's just double check that it does work right off the bat. I'm going to shut off the power. And we're going to turn it back on. See, it might have been just a video capture. Yep, it was. All right, good. So let's go to full screen. So here is the Danny OS running 32K ROM. It's running, like I said before, it's running my system 1.3.1 ROM that we just compiled, or assembled, I should say. And you can see if I dump sections of memory like C1000, that's where actually this ROM chip starts. It does dump out, and that's kind of what a dump looks like on that. We could do certain things here, though. Like I said, the screen RAM starts at 8,000, so we can actually, it'd be pretty funny if we dump 8,000 forward. You can actually see we're dumping portions of the screen, which are pretty funny, just because we can see kind of what's at that memory address. But we do have the ability to do things like peek and poke. So if we peek, let's say starting at 1,000, you can see that's the value that's there. We have a command to poke at 1,000, and we can poke in there, let's say FF. And if we peek that value now, you'll see it's been changed to FF. So that actually means that right here, this static RAM, FF has been written starting at address 1000. Now, what we can also do is add that new, or use that new write command that we started. And you'll see the way that it works is now we can do just bytes in a row. And XX exits. So now if I dump starting at 1000, you'll see you've got there 00, 01, 02, 03, 04, 05. That's what we wrote using that write command. That was a new feature that I just added as well. So we can jump around it even if we need. What we could do now is also, that's an interesting little bug that I think we just see here. I know what that bug is. That bug is that one of the symbols, and I just added this. You see that 0D right there? Starting on page 1068. That 0D is an enter button. That's basically the ASCII key for it. So when it's running through the routine, and we're going to have to change this, it's actually getting to the point where it puts out that 0D, and that 0D is a return, a carriage return. So it's actually making a carriage return right there. Because if you were to dump, from C1000 where there is no 0D, it looks good. But when it tries to display what's in 0D, it's actually creating a carriage return. So we'll mess with that. But I really want to see what BASIC is like. So we have this. This should bootload BASIC, and it looks like it is right away. Memory size we can put in, or we don't have to. Currently, if you take a look at my memory, so if you take a look at how memory is kind of situated here, it's from 00 to 7 FFF, right? I basically am saying that you can use anything above 500 to 7 FFF for RAM. So if we do $500 in hex minus 8,000. Sorry, let's start this again. 500, 8,000 minus 500. You'll see 7B00 would be our upper limit, which would give us 31,488 bytes of available space to basically use its basic RAM. Technically speaking, Enhanced Basic should be able to figure out automatically how much RAM I have available. It should be 31,487 bytes. So why don't we switch over, and instead of actually putting in any type of number here, like 7B00, why don't we just press enter and see what Enhanced Basic figures out. Funny, so it did. It found out perfect. 31,487 bytes. So now basically I'm in Enhanced Basic. I can't get back to the main monitor unless I can either jump back in or I just press the reset button that I've implemented on the 6502, which just pulls the reset vector low or the reset line low, and then it jumps in system ROM over to where reset is, which starts the system over again. So if I do it, you'll see it'll bring us back to the beginning. And if I type basic, once again, we're back in with the same amount of memory that we had before. So this is exciting for me. I know I'm not really showing it, but like I've not had BASIC running on actual hardware before that I created. So we have a version of BASIC that's actually running on hardware. So, I mean, when you got BASIC running, right, what's the first thing you do is you create hello world, right? So 10, we'll do print hello world. 20, go to 10. And let's list this. Look at that. This is really cool. That this basic is running here. All right, so what we'll do is we'll run this and we'll see what happens. Look, exactly what should happen. Basic is working perfectly. I haven't implemented Control C yet. And maybe that will be on a future video, implementing one or two extra keyboard commands. I know I haven't put Control C even in our keyboard decoder. So even though I press Control C, it can't pick that up. So I'll just use the reset button and go back into BASIC. And from here, we can, you know what? Let's find a simple, find a simple BASIC test online that we could use. Let's see, simple BASIC program. And, you know, something like real basic. Now, enhanced basic should pretty much, here, we got the Fibonacci numbers. This is perfect. It should pretty much handle all of regular basic commands. I'm not 100% sure of the syntax of all of the basic commands, so potentially we're going to suffer through this just a little bit together. But here, let's go. Let's go and try this out. So 10, let max equals 5,000. So we're gonna see. All right, looks like, yeah, those commands actually are working fine because we didn't get an error on that. So we're going to let it equals 5,000. 20 is let x equal 1 and let y equal 1. And let's see if the colon notation works. And it does. So we're creating variables inline here. 30 if, and I don't know if you need parentheses at all for if in enhanced basic. I think you just put it on one line, but let's see. If x is greater than max, then go to line 100. Let's run this, and it actually works fine. So you can use parentheses within enhanced basic. So it looks like enhanced basic supports everything that, you know, pretty much other basics would support. So line 40 will print x. Line 50 will say x equals x plus y. Line 60, y is greater than max. Go to 100. 70 will print y. 80, y equals y, x plus y. And 90 is go to 30. And then 100 is just end. So let's list this program. And we see here, let max equals 5,000, x equals 1, y equals 1. Looks like everything is good. So we'll run this. Look at that. Man, I love it. Love it. That's so cool. That is so cool that, you know, this is all built off the shelf parts, kind of just put together, and now we're running BASIC on it. This was, I've never done an FPGA before, ever. So, you know, this was a learning experience for myself, creating, you know, kind of like a PPU for this, as I call it, like a VGA system, subsystem. So I'm not using, this is not like a terminal base. This is real graphics that I've, you know, kind of put into an FPGA using VHDL that I've never really experienced before. And that's kind of the things I want to do on this channel. I want to be able to kind of go through stuff that, you know, is new for me, new for maybe some people out there who are interested in kind of this homebrew stuff. and get into it. Let's see another example if another one works. Euclidean algorithm for finding the greatest common divisor. And then getting user input. Oh, you know what? We should do something with user input. Would like that. So what is this? Wow, some of these are really long. And this is why, like I said, I also need a way to load into this and to, save out of it. Loading first, because it'd be nice to just, copy and paste this into some type of a terminal. Or even just make some circuitry that runs over USB that just dumps byte by byte to the data port, because I got a second data port open on the VIA chip. But let's see if there's another small potentially basic program that we can run that really does a decent compute. Something that is a decent amount of compute. This looks pretty cool, but you need plot. See, plot is not inherently in Enhanced Basic, but you can extend it basically where if I can add it to the ROM, something graphically for plot, which we can add it to the ROM. We could figure out something for plot graphically. We can then extend BASIC in order to use our ROM-based command. And some of these examples are pretty good here, but I don't feel like typing these all out. I really like to add plot, because when we do plot, man, you can do a lot of cool stuff with it. But let's see. There's another simple one here. Wow, these are some complex basic programs that work pretty well. This is interesting. Could probably make this snake game. Because all you're using is just a character. And I actually have multiple characters. Let's just see if I do print character 10. Oh, I would need to actually do a visible character. I think 10 is a space. 41 should be the letter A. Oh no, 41 is that. Or A is the letter A, I think. Nope. Oh, it's all decimal based. Let's look up an ASCII chart. Trying to remember my BASIC. So it's 65, 41 hex, 65 decimal. So if we say print character 40, 65, we do see an A. So I think I have in here 128 characters. So let's do a new. Should empty everything out. Let's do 10. Let x equal 0. How do we do a 4 again? 4x equals x plus 1. Man, I forgot how to do a for loop in BASIC. Oh my goodness. It's been that long, huh? Index it and then increment and then end value? I don't think that's basic. Let's just see. Yeah, okay, it's the to keyword, so it's not a colon. So we don't even need that at 10. 10 we can just say for I equals 0 to 255. And then 20 we can say print character I, and then 30 we can do next x. Next without 4. So apparently I'm not looking at the right one. Let's look at Enhanced Basic Manual. Here we go. Let's just take a look at 4. 4. So variable expression 2. So, and then the step expression, which is not needed. Oh, I have really weird. Okay, no, that's right. Oh, I use for I, and then here I'm using next I, so that's a next I, next X. Okay, let's try this. Okay, let's keep it all on one page. That's all 255 characters. I don't want to print it on separate pages, on a separate line. So how does one print on the same line? Print. If the list of expressions to be output does not end with a comma or a semicolon, a carriage return in a line feed. So let's put a semicolon, we should be fine. So that's just 20 print character I semicolon. Nice. So that's all of what I programmed into our character array. Now everything after I think 128, if you take a look, in fact, let's just make this 10 for I equals 0 to 128. There we go. Actually, 128 is a bit too far too. Oh no, 128 is good. It's not 128. It's... Man, we're getting some rain here. Equals 0 to... Let's see if we take a look at our ROM real quick. For defined characters in our ROM. The document. Oh, where are you? System ROM, there we are. Define characters. I go up to 140 defined. So let's do it to 140. There we are, look at that. So these are all the characters that I've already put in my 6502's defined character ROM. So actually what's interesting is every time you reboot the PC or hit the reset button, the RAM or really the beginning of ROM, the first thing it does is it dumps all of my defined character set into VGA's static RAM, which is right there. So it performs like these byte by byte copies, and the VGA or the FPGA that is a custom VGA kind of PPU basically takes a byte at a time, and it asks, based on certain registers or memory locations, where should I dump this? Where should I dump this into, this 32K ROM? And then it uses basically like a tile set. So at the very beginning, when you start this up, it happens so quickly, but all 140 characters are placed into VGA ROM. So when it's, or RAM, I should say. So when a tile or a number is put into, the dual port memory at address 8000, it knows exactly which image to print out to the screen in that location. So those are all of the available characters, but you can put your own in. And like I said, it holds up to 256, so it's not as if this is the most you can have in. You can have in much more than this. But it's kind of cool to just, with a simple basic program like this, that everything gets printed out to the screen. Pretty neat. I wonder if I can do a 10 print, right? Do the 10 print on let's do some 10 print. So this is it, but I don't know if, let's see if this command works. Yeah, random might not work. Actually, it does give us random. Interesting. So let's do a new. Sorry, it needs to be capital. And let's do character 205.5 plus random 1 go to 10. Okay, it's trying to 10 print something out that's not the 2 characters in that location. So let's reset it. Let's go back into BASIC. Let's see, which character is it trying? A weird character. I think that 10 print uses basically the / and the \. So in ASCII, we're looking at 2F 5C. You know what? We'll have to come up with this another time and kind of do a cool basic string. But right now, I wanted to kind of just get this out here. I wanted to show everybody what this looks like, what the 6502 PC looks like while it's running, the Danny 1. Kind of some of the components behind it. And honestly, if you like this, like if this was cool and right up your alley and you enjoyed this stream, please, throw a like on the video, throw a comment in there. I had planned on, building more things, different things with you guys from scratch. I'd love to do it. If the community wants something or has an idea for something, or if you guys want me, I'll start a Discord and we can kind of say, hey, let's work on this project on stream together, and we can kind of see it come together from, just the creative planning portions of it all the way to instantiation, like it being a physical item that we can touch and hold. But thanks, guys, for watching the video, coming on, checking out the stream. This is the first of hopefully more eventually. I tried to keep the video to around an hour today. But if you like that time, if you want to see more, if you think potentially, hey, listen, after you live stream it, it needs to have some editing done, let me know. And, we can cut down on some things. Well, thanks, guys. I appreciate it. And this has been fun. This is Null Syntax. I'm signing off, and